10 minutes to go over.
Really?
Yeah, this won't take very long at all. What we're going to do here real quick is just kind of, one of the reasons why we're going back into some of these function model things is on the park test you guys took, remember how you guys had some tables of data? You probably just kind of went like this through it. A lot of times, what you guys are going to want to try to be able to do, and this does happen, this is one of the reasons why we want to start showing this a little bit more. So on the park test, they talk a lot about different models, different ways that data is being given to you, and it fits some sort of a model. Whether it's linear, quadratic, exponential, trigonometric, there's some sort of model that they can all follow. And if they follow those specific models, you can easily interpret that data to extrapolate, to come up with a best fit line, if you will, to come up, what's going to happen in 10 years, that kind of thing. That's what it means. You guys know what extrapolate, right? Extrapolate. I will show you what that means here in a minute. So basically, you guys have all done scatter plots. It's basically you plot things on the X and the Y grid, and there's a whole bunch of dots and try to figure out what is the best line of best fit, if you will. There's ways of doing that, whether or not we're going to do it by hand or using our calculator. There's a couple of different ways of setting these things up. So real fast, just real quick reminders. Positive correlation, negative correlation, or no correlation, you're dealing with a scatter plot. Well, scatter plot is just a bunch of data, right? What direction do you think the data would be pointing if it was a positive? Up and
away.
Like that? Yep. What happens if there was one dot all the way out here? It doesn't make, yeah, it's still, the majority of the data appears as it's moving up and to the right. That's where you get this positive correlation. You can have what's called an outlier, something just hanging out over here, or all the way over here, or way even out there. You never know. Okay? It doesn't matter. Negative correlation then is the other way. I know. I'm asking a lot this morning. I know. Actually, that's kind of pretty common. There. And then no correlation would be
Nothing.
Well, there'd be something.
Randomly, they don't really go.
It's like all over the board.
Like, like what is it?
The correlation is not
Okay, let me pick the color. Why don't you let me pick the color? You just want to mess around with colors, is what you're saying?
Like, I want to be a teacher. That's the best one.
You can come up.
You just brighter and smaller. Put it in your book of my house.
Caleb, you look like you're not going to make it, man.
I'm so tired.
Speaking of the car.
Oh, you I did, but that's so hard to do.
It is. I was never one to be able to sleep in a car. So yeah, these are things that you guys have all done. This is an Algebra 1 skill that you guys all learned about prior to talking about slopes. I don't know if you remember way back when, but that's kind of where these things get first introduced. Okay? Question on that? All right, so let's show how this works as far as correlating data. So let's see. I need 7. We'll use 7 people here. Well, this just made a little table. We're going to correlate height versus weight, and that usually helps to interpret. It's kind of an easy one to set up. So let's see. We'll use gentlemen because girls. I understand. It's okay. So we'll start with.
There's like 9 guys.
We'll start with the short guys and work our way to the tall guys.
2, 3.
So Austin and Bing.
We have 7.
No offense,
Yeah. We only have 7 guys.
but it works.
Wait, no,
So-
we have 8. No, we have 9. Wow, I can't count. Oh, wow.
I know it's really difficult this morning.
Oh my God.
So do you know how many inches tall you are? If you're 6 foot, how many inches is that? Don't use your calculator, you're a bum.
2 inches. 62.
No.
72.
I'm 71 inches. I'm 71 inches.
All right, you're 71 inches. How much do you weigh?
150. I do.
Really?
Yeah.
Okay.
72 inches,
Oh,
185.
Okay?
Damn, yours.
Austin?
67.
Whoa. It's called 130.
Caleb, is this too much math for you?
72.
Michael? 70?
Yeah. Short.
All right, Mr. Wesley, what do you got?
72, 130.
You're not just 6 foot. You're taller than that now, aren't you?
Wait, you're 6 foot?
We need to get some heat on the bones.
How much do you weigh? Like 110?
Like Ian, like 95.
Mr. DJ?
Like 74, so he's like 75.
Is he taller than you?
Yeah, he's like, he is tall.
Stand up.
Why don't you stand
Wait, what? No way.
No way!
DJ, you're tall.
Oh, no.
All right.
So you're like 70.
When I stand,
Alright, Wes, you're like
Usually people are taller when they stand. Yeah, that's a good point.
So what?
No. Because when you say when I stand, I'm usually taller. Well, yeah, that's usually how it works. What do you-
2 something.
200.
We'll just say 200 then, all right? So what this has given us is just a real basic generic data set. Everybody okay with that? Now, when you get data sets like this, it's a matter of just plotting it height versus weight. Does it matter which one goes where? Not really. So let's see here. If I want to do a double screen here so we have them both up. If I want to make a scatter plot of Z data, does it matter? Hey, I got an idea. Height. Ah, I see what I did there. Oh.
Doesn't matter height.
Come on, I'm trying to make something that is absolutely boring, somewhat enjoyable.
I thought it was pretty funny.
Thanks. This is why you get along with me-ish. So you have height, and obviously height. What is our shortest? So we'll start it at this. We'll say this is 65, and then let's go up. We only have to go up to what, 74? So let's do 66, and we'll go up by 2. 66, 68, 70, 72, 74. We can still put 0 here. Is it okay that I just scale it up like that?
Yeah.
Doesn't make a difference. Doesn't make a difference. All right. Weights, we'll just start it at, we'll start it at like 125. And we'll go by, we can probably go by 5s?
10.
30? Okay, so what's in here?
Start
135, 145. We'll just do it like that. And when you're dealing with scatterplot stuff, you're just trying to get some visual of the data. It does not, it's not as specific as intercepts that we were working on in 3-4 with the linear programming stuff. It's just kind of give me the idea, is there a positive or negative or really no correlation to this at all? So that's just a matter of putting some dots in, okay? Not Datsuns as in Nissan, it's dots in the graph. You guys don't even know what a Datsun is, do you? Datsun as in a car?
I was thinking of a dog too.
Yeah, me too.
That's a Datsun.
Dots.
I thought it was a
Datsun, D-A-T-S.
Datsun sounds like
It's a car.
Sounds German.
Nissan, no, it's German. They're Germans. Japanese.
No.
Sounds German.
Sounds, yes, the Germans make those Japanese cars so well. 71 inches at 150 pounds. So here's 150, 71, 72, 185, 67, 130, 72, 155. I probably should have flipped it, because this is kind of weird going opposite way around here. That doesn't, it's all right, so one.
Okay, what do you mean for?
Because I'm reading this first as an X, but I'm plotting it as a Y. It doesn't make as big of a deal, it's still gonna show it.
So,
Where are we at? 70?
7145.
Oh, we're at 72.
72. And then 74.
So does it
Now we
look?
connect the dots.
So does it look like as you get heavier, you're probably getting taller?
A little bit.
Kind of.
Yeah.
Not very.
Wes messed the whole thing.
Wes is like,
He's the outlier, right? That's all this is, guys. Could you flip flop and put it on the other axes? Yeah, it probably would have been cleaner to put it at height on the x-axis. It's not that big of a deal. Okay. What you're looking at here is, can you come up with sort of a data set? Now, one of the things that you can do here is come up with what's called the line of best fit. Here's what that means: is what I drew in here kind of is really close to matching up a bunch of these points as they're going through. You've got a couple above and a couple below. I'm trying to take into consideration the outliers up here. That's why it's up a little bit more this way. It might not be bad to take something where it was this point here and connect it out to one of the other ones, like this. See how now I've kind of picked 2 points that kind of represent the best idea of the data? Do you remember how to write the equation of a line given 2 points?
No. Yeah, no.
Yeah, exactly. So if I'm looking at these 2 points, this one was, what was this?
That one's 145 and 70.
And then this one was the 274. So if I take these and we call this our x and our y, I'm going to go back to just this page, okay? Oops. Yeah, that's what I'm going to do. I'm going to find the slopes. What I'm going to do is use these 2 as my ordered pairs, find the slopes, and write the equation out. Here's what happens. We have the ordered pairs of 145 and 70 and 274. And I'm going to find the slope between those 2 parts. The slope, remember, is change in y over change in x. What's the change in y in that?
4.
4.
What? Oh.
You see that? What's the change in x?
55.
55. Can you simplify that fraction? No. So there's your slope. Remember what point slope looked like? Remember that? Did you know that that's your first introduction to H and K? That was an HK problem. Because they didn't want to mess with you when you first learned that. So now just, does it matter which ordered pair I pick? It doesn't make a difference at all. Makes no difference at all. So when I pick this out, I say y, well, we'll use this one, y minus 200, oops, sorry, 74, equals 4 over 55. And this word comes in handy to make sure you have your calculator.
Come back later.
So,
I mean, I will, I'll leave you.
it's fine.
No problem.
So now it's just, now it's just a matter of just using your calculator and getting y by itself. So you have 455x minus be 1,000, or sorry, 800 over 55 plus 74. So you just need to figure out what that is.
What, 800 over 55?
Oh.
Negative 800 over 55.
Oh, negative.
Yeah. And you're going to add 74 to that. We should get a fraction.
We get 654 over 11.
That's what I got. So your equation would be y equals 4 over 55x plus, what was it, 654 over 11.
Yeah. Nice fraction there.
Oh, it's lovely, isn't it? It's lovely. So according to this this would be the equation of if I know somebody's weight, I can figure out their height. Where X is their weight, Y is their height. Does that make sense? So let's see if it works. I'm 6'3", and I'm 190. So if I figure out if that works, I would substitute in 190. How close are we?
I don't know.
We'll find out.
Let's see. I'll use your cup.
I want it to be like close 75.
Yeah, it should be.
806 over 11.
806 over 11. All right, so what's 806
70.
over 11? 73.27.
pretty
So
good.
it's close, about an inch and a half off. But you see how that works? It is that.
70.
You can sort here.
73.27.
Yeah, 73.27. So that says that I'm 6'1" and a third, if you will. It's a little off, but it's not bad. It's pretty close. So that's the kind of things that you can do with these data sets to see how close you can get. Because you can always go back and substitute in your own values for something like this and see how it works. Okay? Not scary? The other way to do it is to use your calculator. You guys remember how to do the list things? Where's the L button? So if you go to, let me back this out. Stat, was it second list, I believe. Hit L1, we're going to hit enter. And our L1 was our X values. Oops, did it not? If I want to edit my list, sorry.
Oh, you do stat, edit, and then you can put the line.
Okay, thank you. Stat, edit. There it is. Thank you. Yeah, hit stat, edit, and go to L1. We're going to put in our list of weights. Okay, put in your list of weights. Can I see it real quick? I'm just going to type it in. So we had 150, 185. Oops. How do you have the day? 130. 155. $145, $130, and $200. Okay. Our L2, we just move over to the other one. Oops. And just type in all of our L2 values. And that was 71, 72, 67, 72, 70, 72, and 74. You okay with that? So we have our, so we have our two lists. Now if you back out again, hit second, quit, just to back out. What we're going to do is we're going to go and use the regression formulas, that are the regression settings in the calculator itself to come up with an equation. So what it's going to do is actually figure out line of best fit. So hit your stat button again. Move over to where it says calculate. And we want to do linear regression because we're talking about linear stuff today. Okay, that's option 4. List 1 was our X values, list 2 was our Y values.
Yeah, I didn't get that. It shows up in there.
And you got to hit enter. Hit enter one more time. And then it's just going to do it right away. I think my operating system's a little bit different, that's all. Now if you scroll through and hit
.058.
so this is telling you what your A and your B is. So it tells you that your A value is .058, where we had it as 4/55. What's 4/55 as a decimal?
I'm guessing that number.
It's .72.
.72?
Wait, what over 55?
.07.
0.4,
Nobody's perfect.
0.07?
Yeah.
So really a couple hundredths off. But you see, the calculator is a little bit more specific at it, right? The calculator would be a little bit more specific. So in this case, the calculator said that our equation, not cool. It's rainbows of happiness for you guys. So the calculator is telling us that the equation should have been y equals 0.058x plus 62.07. So if I try that again, remember what it told me I was going to be 73.27.
Yeah.
It was telling me that's what my height should have been. Well, if I use this one, let's see what it spits out. Again, I was 190. What does it give you here?
73.09.
Really? So it's close. It's close. The reason why it's probably not coming out perfectly is because, well, you guys probably don't know your real weights, you probably don't know what your real heights are, and there's only 7 of you. The more data you get, the better you're going to be able to figure something like this out. That's why, you guys ever heard of something called sample size?
Okay.
Okay. The larger the sample size you have of testing something, the better results become. For example, if I wanted to just, and this goes back to probabilities, if I wanted to take a roll a die, and I roll a die, what's the probability I'm going to get a 3?
1 out of 6.
1 out of 6. So in theory, that means every 6th time that I roll a die, it should be a 3.
That's BS.
Correct, because it's probability. It's theoretical versus actual. This is where sample size comes into play. And we actually do a lot, we do some projects and things like that in a couple of weeks when we do some of the probability stuff.
You say project?
Projects
Yeah.
I remember becoming.
It is, but it's fun. I always have a lot of fun with those. Most people,
That's what they said about making like a building out of geometry.
Oh, the area thing?
yeah, they're doing that right now. Yeah, they just started that now. So we did all this, find the slopes, blah, 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 wrote the equation, did that, predict this. We did this with the calculator. Yeah, I don't even think I need to go through and do another example, do I?
That means no homework.
Do you want to do one more?
Let's do this one.
No.
Let's do this. Go right to your calculator. Let's do it this way, where we're going to go X and Y, so they
Just get
calculate for the list.
on there.
We're going to go right to the list. Hi. We're going to go to the magical mist and list 3 tour. Okay. So, I just love doing that. It's fun. Thanks, man.
For that person who tries to write down their name as one of those.
Yeah, how do you type in the W? Yes, sir.
It says error every single time.
I think there's a button for it.
You go to like
Stat.
stat and then 4 clear list.
Yeah, but it says error every time.
No, you
Argument.
do memory 4.
You can just press delete on the ones that you don't
Second
want.
plus sign. Clear all lists. Number 4.
Ha.
Second plus 4.
Done.
I'm done.
So, did you get an equation for that?
I don't know.
I'm not even, okay. I'm just trying to get to a list.
Yes, ma'am. Some listed stuff. On your calculator, what we're looking at today is linear regression. We're looking at correlating lines of estimate, scatter plots, if you will. Ridiculously easy.
So how do you get to the list?
What I want you to be able to do is know how to create a list and get the calculator to create the equation for you. So if you go to your calculator and you type in, we'll go to your list.
Wait, I feel like 8.188073394.
Just trying to move this over. Bless you.
Let's teach
If you go to your list, let me move this.
How many decimal places do you want to pass for these?
2 probably. So again, we go to my list, stat, edit. We're going to edit L1. Oh, it didn't clear it out. Huh. Whatever. I'm going to say my L1 is going to label in here 16.7, 15.3, 14.1, and 12.7. The other ones I need to delete. Okay with that? Go to the other list. And it was 110.
That sucked that you got 99. Barry Sanders should come out of town and just go one.
You know, it was sad when he just up and retired. He just said, I'm done.
Why
He
did
could
he
have,
not go for 100? What did he do?
you know, he could have easily broken Walter Payton's record, rushing record, when he retired. He still had another 3-4 years in him. I think he just was had enough. He was just done. He made the Bears look so silly so many times. Once you get your lists in, it's just a matter of go back to your stat. We're going to calculate. We're dealing with linear regression, so we're going to put option 4. Enter a bunch of times. And then you have your A value and your B value, so it's giving you your basic equation. Okay.
And when we do that and like all those numbers are like, do we just go to like 100?
Yeah, and that's what Jared was asking about here. So what I would say is when I move this over, what's nice about using this, let me bring it to the next page, is we've got the equation of best fit. So let me put this in real quick. Your equation then would have been y equals 8.19x plus or minus 26.36. That's what I would write that as when I round everything up to 2 decimal places.
So basically, when you put in X, you can find out what touchdown you get.
Yeah. Now here's what happens. If I take this equation, now we have this. I can do the following thing for predictors. Running back for the Steelers. The bus. Yeah. So he was pretty big. He's a big dude. In this case here, if you want to predict the number of touchdowns Jerome Bettis had, your value of X here is
13.7.
13.7. Good, because it's all in thousands. That's where a lot of times you got to be careful with that. So you do write 13.7 for your X value and go in from there. What do you get for touchdowns?
5, 8,
Huh?
85.
85. Oh, I thought you said 5. I'm like, 5 touchdowns? Something's up right there.
85.
I think the bus might have had
Well,
one.
if you round up 86 touchdowns.
Okay. Now, could you work backwards?
Can't round up.
Could you figure out how many yards he had, the edge had?
Like so happy.
Yeah.
The edge.
Yeah.
I think they call him the edge, right? No, that's guitarist from U2. I was getting them mixed up. They're very similar in stature.
I mean, why do you not call it? Edgar and takes forever to say. Edgar and James.
Edgerin.
I'm going Edgar and
Well, the D comes first, so.
Edgar and James.
He's dead.
Yeah.
Well, quote the Raven. Nevermore. It's the best Simpsons episode ever. When they do the Raven. That is so well
Definitely the
done.
best
The Halloween horror one. Yeah. So if they tell you that he has 80 touchdowns, how many yards did he run, do you think?
13,000.
So this stuff is not very difficult, is it?
You just add the 26.
I love the fact that you guys are all so worried that you weren't going to be able to use a calculator for anything. That just means I'm doing my job.
We didn't use a calculator for.
Have you actually figured
I
out the
know.
problem?
Yeah, what?
You add 26.36 and divide by 8.19. And X equals.
How do you solve for what? How do you solve for this? Well, this is
Go back!
80.
You add
You add 26.36 and then you divide.
2 steps. I know it's one day. Sure? All right.
even
I'm worried about you.
Barry did figure it out.
What page is it on?